Part B asks, given that you know it lands way out at D, and then it might give you a value. In my case, they tell me that D is equal to 160 meters. The question is, what's this initial velocity? Horizontal motion in the horizontal portion of projectile motion is a constant velocity. There's no acceleration horizontally because there's no forces horizontally. The only force, once the cannonball is out in the air, is the force downwards due to gravity. That causes an acceleration g, but horizontally there are no forces, no accelerations. Velocity is a constant. The kinematic equation for constant velocity is your final position is equal to your initial position plus the effects of velocity through time. Our final position is d. Our initial position x is 0. Our velocity is v naught. And the time, delta t, is final minus initial. Initial 0. Final is that time that it took to hit the ground. If the question is v naught, you simply have to, we know time that it took to hit the ground. We calculated that in part A. We know the distance, we were given it. Just solve for this v naught. Algebra. The distance divided by the time. You even have the units. Distance is in meters, time is in seconds. Meters per second is the velocity. Part C asks, what is the vertical position of the cannonball when it's at half the distance? Well, the interesting part, well, not interesting, because motion, the horizontal motion is constant, the halfway point in distance is the same as the halfway point in time, horizontally. So the time that the ball has moved half the distance out to D is half the time it takes to hit the ground. So these 2 points actually correspond, or these two correspond. So it's actually the same height that you've calculated in the first case. The vertical position when you've covered half the distance to impact is the same position as when you've covered half of the time, because it moves steadily through time and the horizontal direction. It's accelerating in the vertical direction, but in the horizontal direction it's steady in time and space. So the answer to C is exactly the answer that you had to A.